What if I told you that one of the most transformative, most complex weeks of your entire life happened when you were smaller than a poppy seed? Yeah, seriously. We're going to dive into the third week of embryonic development because this 7-day stretch, well, it lays the foundation for literally everything you are.
So, picture this. At the start of week 3, we're basically a simple 2-layered disc. That's it, an epiblast on top of a hypoblast. But by the end of those 7 days, that simple structure is completely transformed into a complex 3-layered blueprint for a human being, with these new layers we call the ectoderm, mesoderm, and endoderm. The change is it's absolutely staggering.
So the big question is, how on earth does biology pull this off? How does it orchestrate this incredible construction project, going from a flat little disc to a complex body plan in just 1 week? Well, the answer lies in a series of perfectly timed, brilliantly executed events. The first, and you could argue the most important event, is called gastrulation. The best way to think about it is as a great, coordinated migration of cells. This is the moment the embryo goes from being a 2-dimensional sheet to a 3-dimensional structure. It's building the very foundation of its form. And this whole migration, this grand cellular journey, it has a very specific starting line. It all kicks off with the formation of a structure on the surface of that top layer, the epiblast. And that structure is known as the primitive streak. Okay, so here's how it goes down. The primitive streak basically acts like a cellular highway. First, it appears on the surface. Then, epiblast cells start moving towards it and literally dive right in, a process we call ingression. The very first cells that take the plunge replace the old bottom layer to form the endoderm. The next wave of cells spreads out right in the middle, creating the mesoderm. And what about the epiblast cells that stayed on top? They get a new name, the ectoderm. And just like that, 3 brand new layers are born from 1. And these 3 layers, the ectoderm, mesoderm, and endoderm, they are everything. These are the master building materials, the foundational tissues that will give rise to every single organ and structure in the entire body. You've got your outer layer, your middle layer, and your inner layer, the whole shebang. This quote from Professor Yama really just nails it. It tells you how powerful that original top layer was. The epiblast is the source of all of it. Through this process of gastrulation, this single sheet of cells creates the whole trilogy of tissues that will build a person. It's pretty much the ultimate ancestor of all your cells. All right, so we've got our 3 layers. What's next? Well, the embryo needs a central plan, right? An axis. This is where the notochord comes into play. You can think of it as the embryo's head architect, setting up the main axis of the body and telling all the other cells where to go and what to become. Now, to get where the notochord comes from, we have to look at that new middle layer, the mesoderm. It doesn't just sit there as one big sheet. Oh no, it quickly gets organized into these distinct regions. And it's that central-most column, the one we call the axial mesoderm, that condenses down to form the notochord. The best way to think of the notochord is as the embryo's very first scaffolding. It's this solid central rod that gives structural support. It defines the left-right and head-to-tail axes, and, most importantly, it sends out these critical molecular signals to all the tissues around it, basically giving them their construction orders. And believe me, its most important job is still to come. And that brings us to the third massive process of week 3, neurulation. This is where those signals from the notochord kickstart the formation of our entire central nervous system. I mean, this is quite literally the first draft of the brain and spinal cord being drawn up. It's incredible. So how does this even work? Well, that notochord, that scaffolding we just talked about, sends a powerful chemical signal straight up to the ectoderm layer that's sitting right on top of it. It's a direct instruction from the mesoderm to the ectoderm. And that instruction is so simple, but so profound. It tells a specific part of the ectoderm to fold in on itself. It's this brilliant move, really. It's how a flat sheet of cells starts to create a complex, hollow tube that's going to become the command center for the entire body. And this folding, it happens so fast and with amazing precision. The tube starts to zip up from the middle and then moves outwards. By day 25, the cranial end, that's the future brain, seals shut. Just 2 days later, on day 27, the caudal or tail end completes the seal. The whole thing is done in just a matter of days. So let's take a breath. By the end of this whirlwind week, we have our blueprint.
We've gone from 2 layers to 3. We've set up a central axis, and we've folded up the very beginnings of a nervous system. From these 3 simple germ layers, endless possibilities are about to unfold. And this chart just lays it all out so perfectly. The ectoderm, our outer layer, that becomes our nervous system and our skin. The mesoderm, that middle layer, is the real powerhouse. It forms the skeleton, muscles, heart, kidneys, you name it. And the endoderm, the inner layer, becomes the lining of our gut and our lungs. Literally everything in your body right now can be traced back to one of these 3 original layers. So we have gastrulation, we have the notochord forming, neurulation. It's all a very delicate and precise biological dance. But, because it is so precise, what happens when a step gets missed, or the timing is just a little bit off? Well, the consequences can be pretty significant. Let's look at 2 extremes, both related to gastrulation. It's like a Goldilocks situation. If the process is overactive and goes on for too long, you can get something called a sacrococcygeal teratoma. But if it's not strong enough, if there's too little, it can lead to a rare condition called sirenamolia. It's a really stark reminder of how critical precision is in biology. See, the primitive streak is supposed to shrink and disappear by the end of the 4th week. But what if some of it sticks around? Its cells, which are what we call pluripotent, meaning they can become anything, can just keep dividing. This can lead to a sacrococcygeal teratoma, a tumor that can bizarrely contain all kinds of different tissues, like hair, teeth, muscle, all because it's derived from cells that can form all 3 of those master germ layers. Now, on the complete opposite end of the spectrum is sirenamolia, also called mermaid syndrome. This is what can happen when gastrulation is insufficient, when just not enough mesoderm gets formed in the lower or caudal part of the embryo. Without enough of that middle layer to build the structures of the lower body, the limbs can end up fusing together. So, as we wrap this up, it is just incredible to think that in 7 short days, a simple 2-layered disc becomes a complex 3-layered embryo with the foundations of a nervous system. This week of wonder, even though it was completely unseen and unfelt by anyone, is the biological bedrock upon which your entire existence is built. And it really leaves you with a final thought, doesn't it? The 3rd week is an absolute masterclass in biological engineering. It sets the stage for everything that comes next. But it makes you wonder, what other microscopic, perfectly choreographed events in our earliest days were just as crucial in defining the people we all ultimately become?